Assalamu alaikum student. Today my topic is heat. Heat is the form of energy that is transferred between system or objects with different temperature, flowing from the high temperature system to the low temperature system. Also referred to as heat energy or a thermal energy. Heat is typically measured in calories or joules. These are the unit of the heat, and the heat has the two theories. The famous theory number 1 is caloric theory and the second one is mechanical theory. In this lecture, I will discuss about the caloric theory. Now let's start. The caloric theory is an obsolete scientific theory that heat consists of a self-repellent fluid called caloric that flows from hotter bodies to the colder bodies. Caloric was also thought of as a weightless gas that could pass in and out of pores in solids and liquid. In the caloric theory, the heat flows from hotter bodies to cooler bodies, yani colder bodies. Benjamin Thompson, American, born British physicist Benjamin Thompson Scott Rumford, age 1753-1814, is the best known for his attacks on the caloric theory of heat. Is the founder of the caloric theory. Benjamin was born on March 26, 1573 in Woburn, Mass. He received only 2 years of formal education and at 13 was apprenticed to a local merchant. Benjamin was the founder of the caloric theory. He was American physicist. Carnot showed that the amount of mechanical work that can be obtained from a given amount of heat energy by such a device is independent of the material that does the physical work. With a quantitative relation between heat and mechanical energy established, the caloric theory becomes far less credible. When the mechanical theory is informed, the caloric theory becomes far less credible. Carnot introduced the mechanical theory of the heat. Quantitative relationship between heat and mechanical energy established by the Carnot. Caloric temperature. Caloric temperature is supposed to be the correct average temperature between inlet and outlet of a stream. When using the stream properties at that temperature, one should, in theory, obtain those film coefficient Hi and H0 for tube and shell sides that would result in the correct Q value of the exchanger. I repeat, caloric temperature is supposed to be correct average temperature between inlet and outlet of stream. When using the stream properties at that temperature, one should in theory obtain those film coefficient Hi and H0 for tube and shell sides that would result in the correct U value of the exchanger. Thank you.